Okay, once again, welcome back. And, let me just make sure that I actually am recording here. I did this one time and got a whole lesson done and found out I never was recording. Yep, I am. We're already 10 seconds in. Okay, we are about to check page 357, one of the easiest assignments of the entire year. Number 2, right here on the board. We've got this equation, this quadratic equation, x squared plus 10x plus 25 equals 0. You were not to find the solutions. If you did find the solutions, it's doubtful that you really understood what you were supposed to be doing. We're supposed to be using just the discriminant. What is the discriminant? Ah, yes, you know. The discriminant is b squared minus 4ac. We use the discriminant to find out how many and what kind of solutions this would have if we were to find the solutions. By the way, a quick glance at that equation says it would be so easy to factor. In fact, factoring it would be what? X plus 5 times x plus 5. So the solutions will be just negative 5. Okay, but we're not supposed to know that. We're going to find the discriminant anyway. Oops, erased it too much. Come on back, come back, come back. Okay. So what is the discriminant? It is b squared, that's 100, minus 4 times 1 times 25. That's minus 100. Oh, this is a situation where the discriminant equals 0. Because the discriminant equals 0, that means that in the quadratic formula, the plus or minus part would be gone. And if there's no plus or minus anything, then you're only going to get one solution. It will be real. And it will be rational, by the way. So, again, the book did not ask you whether it was rational or irrational. We simply can say that you end up with one real solution. That's all. One real solution. A quick reminder, why is that? Well, the entire quadratic formula, x equals inverse b plus or minus square root of b squared minus 4ac all over 2a. If this is 0, square root of 0 is 0, plus or minus 0 is irrelevant, we end up with just one solution, which would be inverse b over 2a. And it's clearly going to be rational. One rational root. All you had to do was say one, well, I think the book does specify to say one real root. It's not imaginary. Yeah. So you should say one real root. All right. For the rest of these, because they're so easy, I'm just going to give answers. Number 4, b squared minus 4ac. By the way, in the case of number 4, b is 0. There is no x term. We've got an x squared, and we have a constant term of 2. We don't have an x term. So b is 0. So we have, oh, excuse me, b squared minus 4ac, forget that, that's the old problem. And because b is 0, we have 0 minus 4 times a times c, minus 4 times 1 times 2, that's minus 8. We get a negative answer, which means since the discriminant is negative 8, that's what I need to see on your paper, that you know that the discriminant is negative 8. And that means you're going to get two imaginary roots. Because you can't take, in the real numbers, you can't take the square root of a negative. And you've got the plus or minus in there, you're going to have two imaginary roots. Number 6, the discriminant, again, there's no b term, that's interesting, or no x term I should say, so b is 0. So this time you get a discriminant of 20, positive 20, which means you're going to get two real roots. And they happen to be irrational, although again the book never made that distinction, but you would have two real solutions. Number 8. Let's see, I can't read mine right. What does that say? Oh, I see what it says. Okay. Yes, for number 8, b squared minus 4ac turns out to be 100. Yep, 44, 144. And because the discriminant is 144, that's positive. Therefore, we're going to get two real roots. And we could add in that because we know the square root of 144, they'll not just be real, but they will be rational. But I'm not expecting you to say that because the book never mentioned it. Number 10. Number 10. We get a discriminant of -7. -7. Which means you're going to get 2 imaginary roots. 2 imaginaries. -7 gives you 2 imaginaries. Number 12. We get a nice, neat 49 for the discriminant. I need to see that on your paper. 49. Therefore, you're going to get 2 real roots. And because we know the square root of 49, it just happens that they'll be rational too. You get 2 real roots. And number 14, how far did this end? Is 14 the end? Yep, 14 is the end. For 14, a little bit ugly this time, but that's all right. You can deal with ugly. And I'm not going to go through the math on this one. But my book says, my answer here I wrote in says you get a discriminant of +7. With a positive discriminant, that means you are indeed going to be stuck with the plus or minus. So you're going to get 2, and it's not negative under the radical, it's +7. So you're going to have 2 real roots. And by the way, because we don't know the square root of 7, we know that not only will they be real, they will be irrational too. But the book didn't ask that. And we're done. There were only 7 possible. We'll call that 8 divided by 4. You can miss 2 instead of a 4. You can miss 4 instead of a 3. You can miss 6 instead of a 2. You can miss all 7 instead of a 1 if you really tried. Put your name on the paper. Pass them up quickly. Quickly. I don't know why some of you always take like 5 minutes to patch your paper up. I don't understand. Mark them quickly because we got some really cool, really important, and deep, deep stuff to look at today. If we don't finish, that'll be okay because we can always continue tomorrow when I come back. But let's see how far we can get. By the way, how much time has this video taken so far? So far we are at only 7 minutes. Man, we're flying. Okay, so I can take about 30 minutes for this next topic. Now, we are actually going to do a little bit of a time warp here. We are in section 8.4. We're going to jump all the way up to section 11.2. I don't understand why the book writers didn't put today's topic in chapter 8. But they waited until chapter 11. So we're going to jump ahead all the way up to page, what page is this? Page 487. What? Yes, page 487. Page 487, and we're going to do the coolest thing you've ever seen. This might even be cooler than the quadratic formula. This is super special stuff. I'm on the wrong page, 487. I'm on 457. 487, come on, I can get there. Here it is, 487. Ooh, I have a note here that says that this whole thing is covered in a smartboard file I called, well, you know what that means? That means I'm going to have to ask the board to give me a new file, which means we get to sit here and twiddle our thumbs while we wait. Let's see, I want to open Algebra 2, page 487. Algebra 2, page 487. Page 487. Page 487. And there it is. Click and open. And now we wait. We wait. And 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 we wait.
Well, hello there. Where am I? Well, oh, hello there, everybody. Oh no, the green stuff is coming up into my head. Oh no. Help me, help me. Bye.
Okay, folks, I'm back, ready to go. I had a little accident while we were waiting for the board. My body seems to have stiffened up some. I don't understand what's going on there. But let's see. Oh, there! It finally came up. Almost. White screen. Come on. And haha! There it is. Now we're good to go. Tell you what, let me go ahead and get the real Mr. Peer, okay? Okay. All right, we're back. Here's the topic of the day. Oh, this is marvelous stuff. Marvelous stuff. We have been solving quadratic equations. Quadratic equations are equations of the form ax squared plus bx plus c equals 0, where the exponent is a 2. We call that a second degree equation because the highest exponent is 2. That is a second degree equation. We are now going to be solving third and fourth degree equations. Yes, we're going to start having exponents of 3 and even 4. How do we do that? It must be complicated. No, it's really not bad at all. It's downright fun. This is the kind of stuff you show your papers to your parents. They look at your paper and say, wow, you are a genius. Look at what you're doing. We need to give you a car. And your parents will buy you a car to celebrate your incredible intellect when they see your papers, because this stuff looks impressive and it's fun. But you're going to know the secret. Yes, it looks impressive, but the secret is it's actually pretty easy. Tedious, yes, it may be tedious. Remember, do not ever think that tedious is the same thing as hard. If you believe tedious is hard, then that means you are lazy. Tedious is not the same thing as hard. What we're going to be doing is actually pretty easy, but it is tedious. All right. We want to find a root of x cubed plus 6x squared minus x minus 30. Now, I'm trying to remember here, how did I want to approach this? Okay, oh yes, all right, we're going to dive right in. Now, we know that if we factor this thing, because it's third degree, we would have to have an x times an x times an x someplace in there. So the factors are going to be x plus or minus something times x plus or minus something times x plus or minus something. The task is to find out what are those three factors. They will be equal to, well, if we're going to solve, if this were an equation, if it were an equation to be solved, let's get rid of the function notation here. If it were an equation to be solved, we would just have to ask ourselves, what's it take for this to be 0? What's it take for that to be 0? What's it take to get, for that to be 0? We would get 3 answers. Yes, no longer just 2, but now we'll be getting 3 answers. So here's the question then. How in the world do we know how to factor this thing? All right, first clue. Whatever we put here and here and here, they're going to have to multiply to give negative 30. Because yes, multiply the last by the last by the last, and it will give you the last term here. So these guys have to multiply to give 30. Which means all 3 of these guys have to be factors of 30. There could be a 1 in here someplace. There could be a 2. 2 is a factor of 30, 2 times 15. There could be a 3. 3 times 10. Could there be a 4? Nope. None of these could be a 4. If any of these were a 4, they would not multiply to give 30. 4 is not a factor of 30. There could be a 5 in there. 5 times 6. There could be a 6. 6 times 5. Can't be a 7. Can't be an 8. Can't be a 9. Could be a 10. Could be a 10. 10 is a factor of 30. What else? There's only one more. Well, there are 2 more. It could be a 15. Or the last one, it could be a 30. It could even be, for all we know, it could be plus 1, minus 1, and plus 30. Would that work? Yeah, those guys multiply to give, that could work. So how do we find out what it is? Here's the trick. We go back to something we saw some time ago that we haven't seen in a while. We're going to use synthetic division. Oh, goody, we like synthetic division. Good. Someone else is probably saying, I hate synthetic division. Get over it, because you're going to be needing it. All right, so here's what we're going to do. Let me get rid of that little circle there thing. It's kind of bothering me. Oops, no, I don't want to do it that way. I'm making a mess here. Select the circle and delete it. Okay, now, let's do synthetic division. Remember how we do this. We pull down the coefficients. 1, there's an invisible 1 there. 1, 6, -1, and -30. We pull down the coefficients. Then we put the box over here. Remember this? Oh yeah, I remember now. Good. Now, what are we going to divide by? We want to divide by factors of 30. Now, I would recommend that you always start with 1 or -1. Because 1 or -1 often does work, and it's the easiest possible thing to plug in here. A 1 or a -1. So let's start with a 1. Well, what's the purpose? You'll see in a moment. Let's put a 1 in here. Now, do you remember how to do synthetic division? Yeah, we remember. Good. Bring down this guy. I need some more space here. I write too big. Okay. So I bring down the 1. There it is. Then we multiply this guy by the number in the box. 1 times 1 is, take out the calculator, 1. It goes diagonally over here. Then we add. We always add. 6 plus 1 is 7. Then we do it again. 7 times 1 is 7. And we add. That gives us 6. We have 6 times 1 is 6. We add, we get -24. And what does that tell us? This says if we were to divide by x minus 1, we would get a remainder. If we would get a remainder, that means that x minus 1 did not go evenly into this thing because we got a remainder. So it didn't work. You're going to need a good eraser for this. Because when you find one that doesn't work because we got a remainder, then we erase everything. There's no need to start all over because you've already got this written up here. Just erase your old work here. Leave that 1 there. But change that 1 to, what's the second easiest number in the world to plug in here? -1. Let's try -1. We've brought down the 1. We multiply 1 times -1 is -1. We add, we get 5. We multiply 5 times -1 is -5. We add, we get -6. We multiply and we can already see it's not going to work. We're not going to get a 0 down here. The moment you see it can't work, bail out. Just bail out. You don't need to finish it if you can see it's not going to give you a 0. So, if 1 didn't work and -1 didn't work, what do we try next? Well, let's go to the next easiest pair of numbers. 2. Is 2 a factor of 30? Yes. So is it worth trying? Yes. We'll try 2. All right, we do it again. You're going to get a lot of practice in synthetic division on this one. And again, make sure you've got a good eraser. Don't use ink. Yeah, you know who I'm talking to. Don't use ink. 1 times 2 is 2. Add, we get 8. Multiply, we have 16. Add, we have 15. Oh, look at this. 15 times 2 is 30. Add, we get 0. We found one. Congratulations. Yes, it feels so good. We have found a factor. Oh, what is it? The factor we found was, remember, change the sign. We found a factor of x minus 2. If that's a positive 2, the factor is x minus 2. So what's that mean then? That means that our partial factorization is x minus 2 because 2 gave us a remainder of 0. Oh, wait, I put the smiley face in the wrong place. 0, there we go. What's the other factor? Well, here it is. So it's x minus 2 times 1x squared plus 8x plus 15. Now we could use synthetic division again to get the next step, but once you get it down to a quadratic, look how easy this thing is to factor. X plus 3 times x plus 5. 3 times 5, 3 plus 5, Don't forget to bring this guy down. And now we see our two solutions. If this were, I don't know, did I express it as an equation before? Yes, I did. We see our two solutions, which are three solutions, which are positive 2, negative 3, and negative 5. Any one of those three numbers, when placed back into the original equation, would make the statement true. Pretty cool, huh? I think so. Let's see some more examples. I probably have an example on the next page here in this old file. Yeah, all right. Let's factor and solve this dude. All right, what's the key? You start with synthetic division. That's it. You start with synthetic division. Now the cool thing is, if you see a third or fourth degree equation, and you simply remember, oh yeah, I start with synthetic division, then the rest of it just kind of falls in place, and you start remembering all of the other steps. You just have to remember to start with synthetic division. So our coefficients are 1, 2, negative 5. Watch out for those. Some folks forget about the negatives like they aren't even important. Yeah, they're important. And negative 6. All right, what goes in the box? We're only going to try numbers that are factors of 6. There's no point in trying, for instance, a 4. 4 is not a factor of 6. There's no point in trying a 7. No, we're going to try only factors of 6. 1 or negative 1, 2 or negative 2, 3 or negative 3, and once we get halfway, there's no way you're going to have to go all the way to this. We're going to find our solution someplace in here. Let's dive in with the easiest possible thing to put in, because it often does work. A 1. I bet it works this time. I don't know. I don't remember. But let's find out. Bring down this first term here. It's like 1 plus nothing is 1. Then we multiply. 1 times 1 is 1. Add, that's 3. Multiply, 3 times 1 is 3. Add, that's negative 2. And we see right now, nope, not going to work. Negative 2 times 1 is negative 2. As soon as you see it's not going to work, don't bother finishing. Just erase and start over with the next logical choice, which would be negative 1. We've brought down our 1. 1 times negative 1 is negative 1. Add, we get 1. Multiply, we get negative 1. Add, we get negative. Oh, yeah. Negative 1 times negative 6 is 6. Add, we get 0. Ta-da, we found it. Yay. So what's that tell us? That one of our factors is going to be x plus 1. Change the sign. One of our factors is x plus 1. The other factor is 1x squared plus 1x minus 6. And again, as frequently happens, in fact, almost always happens with the problems I'm going to give you, as frequently happens, this final quadratic is easy to factor. X plus 1. Again, we could use synthetic division again to finish up here, but why bother when this guy is so easy to factor? X plus and x minus, it'll be a 3 and a 2. They multiply to give negative 6, they add to give positive 1, so we've got it, equals 0. So your solutions are negative 1, negative 3, and positive 2. We've got it. Ta-da! We could take time to check it, but we're not going to. They work. We're done. Pretty good, huh? This really is easy. Yeah, I thought so. All right, let's do this one. Can't do too many examples, can you? No, I guess we can't. Okay. By the way, again, I'm always afraid of running out of time. I don't want to go past your 45-minute period here. So far, I've only used 24 minutes. Cool. I still have plenty of time. All right. So, this is a third-degree equation. just like this one was third degree, right there. Just like this one was third degree, right there. The highest exponent is the degree. So, and there's another. No, there isn't. Never mind. So, being a third degree equation, we will use synthetic division. You'll be doing this a lot in pre-calculus next year as well. So, I start with my coefficients. Make sure there are no missing terms, by the way. I've got an x cubed, x squared, x to the first, x to the 0. Nope, no missing terms. 1, -7, 7, and 15. Watch out for the negatives. Don't think they're unimportant. There's the box. There's this. The only thing I'm going to plug in here will be factors of 15. So I would not bother trying. Well, would it hurt to try it too? It wouldn't hurt. I just guarantee that it won't work. Because 2 is not a factor of 15, so 2 can't work. So why bother trying? Yeah, there's no harm in trying, except you're wasting your time. We want to try only factors of 15. Positive or negative 1, positive or negative, what's next? 3, positive or negative 5. Those are the only things we would want to try. So, let's dive in. Try 1. 1 has to work on one of these. So I don't know the answers. I haven't looked at this since last year. But I have no idea what the answers are going to be. So, bring down the 1 as always. Multiply, that's 1. Add, that's -6. Multiply, that's -6. Add that, no way. It ain't happening. It's not, we need a -15 here, not happening. Oh well, erase. Start over. Let's try a -1. Bring down the 1. 1 times -1 is -1. Add, that's -8. We always add. Don't let me catch you subtracting these. We always add. -7 plus -1 is -8. Okay, multiply again, we get 8. Uh-oh, look what's going to happen. I shouldn't say uh-oh, I should say, oh boy, look what's going to happen. 7 and 8 is 15. Multiply by -1, we get -15. Bingo, we got it, 0. Haha, yes. So that means always change the sign. One of our factors is x plus 1. The other factor is 1x squared minus 8x plus 15. And this guy, again, is easy to factor. Bring this down. And factoring this dude, we have x minus 3 times x minus 5, because -3 times -5 is positive 15. And -3 plus -5 is -8. So our solutions, there they are. -1, positive 3, and positive 5 all work. Not bad. Pretty impressive looking, but not bad. Not bad at all. All right, do I have any more examples here? Yes, I do. Let's continue on. We've got time. Another third degree equation, which says we're going to use synthetic division. Coefficients, 1, 3, -9, and 5. No missing terms, we're fine. This is kind of nice, because there are only 2 possibilities. Well, really, there are 4. It could be plus or minus 1, or it could be plus or minus 5. There are no other possibilities. All right, let's try 1. Surely 1 has to work this time. We haven't seen 1 work yet. Bring down the 1. Let's get some more room. I don't like squeezing it into the bottom. That's a little better. All right, 1 times 1 is 1. Add, that's 4. Multiply 4 times 1 is 4. Add, that's going to be -5. There we go. We got 1. -5 times 1 is -5. Add, we get 0. Congratulations. Yes, indeed. Another, we got to put a smiley face there. Okay. So what do we have? That was a positive 1. Therefore, our first factor is x. Change the sign. X minus 1 times what? Times 1x squared plus 4x minus 5. And this one is also easy to factor. Hey, what if it wasn't easy to factor? What would you do? Could we just use the quadratic formula? Yes, you could just use the quadratic formula, because this is now a quadratic. but this is too easy to factor. Why would we go to the trouble of the quadratic formula when we can factor that with the greatest of ease? And we have x plus 5 times x minus 1, because 5 times negative 1 is negative 5. Yes, 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 I'm reviewing basic factoring that you learned back in Algebra 1. I can't help myself. 5 times negative 1 is negative 5. 5 plus negative 1 is positive 4. We've got it. Solutions are, oh well, assuming this is an equation equal to 0. Solutions are 1, negative 5, and positive 4. Oh, look at this. I didn't even notice. X minus 1. X minus 1. It shows up twice. I could have written that as that. Do I need to list 1 twice? No. It either is or is not a solution. It is a solution. Why mention it twice? That's like taking attendance and saying I've got Johnny and Clyde and Bonnie, and I've got Johnny. Why would I list Johnny twice? Why would I list 1 twice? Don't do that. That's silly. Go to college class and you're in calculus and you list 1 twice. Everyone in the class is going to see you do that, and they're going to laugh you right out of the room. Ha ha ha! Look what he did! Ha ha ha! No, just list it once. Okay. All right, moving on. Do I have any more examples here? I have no idea. Let's see if there are. Yes. Oh, 4th degree. Ha ha! Yes, our first 4th degree. This is so much fun. Pardon me for being so excited. How much time have we taken so far? 31 minutes. Ooh, okay, I don't want to go too close to the 45 limit. We can do this. Our last example, 4th degree. What in the world do we do with a 4th degree? Same thing. 4th degree. Pull down the coefficients. 1, 1, negative 11, negative 9, and positive 18 are coefficients. We'll be bringing that 1 down as always. And as always, I didn't leave myself much room down there. What am I going to put in the box? It has to be factors of 18. We've got quite a few to choose from. But we'll always start with the easiest, because the easiest one often actually does work. So we'll start with 1. All right. Multiply. 1 times 1 is 1. Add, that's 2. Multiply, that's 2. Add that, I think something nice might be happening. Add, we get negative 9. Multiply, I get negative 9. Look at this. Yeah, I can see it's going to happen. Add, we get negative 18. Multiply, we get negative 18. Add, and we get 0. All right, we got it already. Little evil-looking grin there. Okay. So what's that tell us then? Yeah, Mr. Priss, got a problem with this. Not really. Our first factor, change the sign. How many times must I say that? Change the sign. First factor is x minus 1. By the way, if to get this factor, we change that sign, what's that tell you? That the number here that worked actually will be one of your solutions. Any number here that works will be one of your solutions. Oh yeah, pretty cool, huh? So what's this is called a partial factorization. The rest of it is, now we started with x to the 4th, and we divided by x, so this must be x to the 3rd, plus 2x squared, minus 9x, minus 18. So now what in the world do we do? I'll bet you can guess. I'll give you 4.3 seconds to guess. Yes, you are right. We start all over again. We now have here a 3rd degree equation. We use synthetic division again. Let me show you a little trick to save you some work. We always like to save work, right? I'm going to move this elsewhere. Let's move it down out of the way. The board glitch is not letting me select that the way I want it to. There we go. Okay, let's move that down out of the way for a moment. The coefficients would be 1, 2, negative 9, and negative 18. But here they are, 1, 2, negative 9, negative 18. Why do I need to copy them again? I don't. I'm just going to start over, ignoring that remainder of 0. I'm going to start over, and I've already got it written there. Why write it again? Just keep on working down the page. Oh, Oh yeah, that's pretty cool. Oops, get some, oh, what have I just done? I have no idea what I just did. Am I still on the right page? What in the world? Where am I? Somehow I went to the other page. Okay. So I'm just going to keep working down the page. So put my box here. I get my ink. Put my box there. Okay, there we go. Thank you. Line across there. Bring down the 1. Now this time I still need factors of 18, just like I had before. 1 worked once. Could 1 work twice? Yes, it could. So is it worth trying again? Yes. Because if it works again, you don't want to miss it. Oh, here's another nice little thing. Focus on this for a moment. If you've fallen asleep, wake up. Listen to this. Suppose you make a careless mistake someplace and you miss one of the factors. You made a careless addition mistake and you got a remainder and you really weren't supposed to. It was supposed to be 0, but you messed up. Is all lost? No. You simply continue putting numbers in the box until you find something else that works. Because this one is going to have 4 answers. 4 different numbers would work. If you miss one of them, then hopefully you'll find one of the others. And you'll end up at the same place. Although your work might look different than somebody else's work, you'll still end up at the same place. Nice to know you can make a careless mistake someplace and never notice it and continue on and still end up with the correct answer. All right, so let's try 1 again. You never know. Hey, let's switch to white so it always stands out here what we're doing. Okay, there, 1. All right, we multiply. 1 times 1 is 1. Add, we get 3. Multiply, we get 3. Add, we get -6. Multiply, we get negative. Nope, no way. Don't bother finishing. You're wasting your time. Try -1. Bring down the 1. Done. 1 times -1 is -1. Add, we get 1. Multiply, we get -1. Add, we get -10. And multiply, nope, no way. Forget that. I'm going so fast as possible, I might miss something. But if I do, we'll catch another number later. Should I try 2? Well, yes, because 2 is a factor of 18, so 2 is worth trying. Bet you it works. Put a 2 in there. Bring down the 1. 1 times 2 is 2. Add, that's 4. Multiply, that's 8. Add, that's negative. Nope, didn't work. -1 times 2 is -2. No way. No way, Jose, as they say. So let's try a -2. Something's got to work. Bring down the 1. 1 times negative is -2. That's going to be a 0. 0 times -2 is still 0. Ah, yes, I see what's coming. Add these, that's -9. Multiply negative times negative is +18. And bingo, we got it. Yay. We got a factor. So, oh, what's this down here? I don't know what that is. Oh, that was my old partial factorization. Let's just get rid of that now. Because now I know that after the x minus 1, I have changed the sign. X plus 2 times this. Ooh, look at this. 1x squared plus no x minus 9. Hey, look at that. It's our old friend. It's a difference of squares. Can't get any easier to factor than that. And yep, you better be able to do this like in your sleep. X plus 3, x minus 3. Our solutions are 1, -2, -3, and +3. Ta-da, congratulations. Mr. Pierre? Yes? If we're really lazy, can we just write this as plus or minus 3? Yes, you can. Yeah. A waste of mental effort, perhaps, but yes, you can. I don't care. And we're done. We solved our first 4th degree equation. Pretty cool, huh? I think so. All right, that's all I have for you. So with that being all I have for you, here's your assignment due tomorrow. Let's see. Okay, that's not going to be true. That's okay. Your assignment is page 489. Wow, almost page 500. Numbers 18, 20, and 22. Actually, 18 through 24 even. 18 through 24 even. 4 and only 4 third degree. Oh, actually, it's two of them are third degree. That last one, number 24, is fourth degree. That'll be fun. Yes, you're looking forward to it, I can tell. So we have three third degrees and a fourth degree equation to be solved. And that's that. If you get confused or lost, you can flip back a page or two and see their example. Example 2, back on page 486, is a good one. Other good examples, example 3 looks good. Yeah, there are good examples here. Example 1 is a marvelous example. No, it's not. Example 1 is just a review of how to do the synthetic division. Anyway, you get the idea. All right, I will stop babbling now, and hopefully I haven't gone too close to the 45-minute limit, and we will see you tomorrow.
Goodbye.
Oh, 40 minutes. Wow, that's pushing it.